In this problem, we want to practice on the Riemann integrability of a given function. So the simplest function is what's known as the Dirichlet functions, or the Dirichlet function. And this one is very interesting because, as we have seen before, this function does not have a limit anywhere, is not continuous anywhere, and more importantly is that the set where the function jumps, okay, from 0 to 1, uh, for example, is this set Q. If you remove Q, for example, from the interval AB, then basically it's like you didn't remove anything because the rationals between A and B are countable. And the set we'll see later on when we talk about the Lebesgue integral that the countable sets are almost like nowhere to be seen in terms of measure. Okay, what we call negligible set or set of measure 0. So this function is what we are going to show in this problem is that it's very bad when it comes to what? To the concept of Riemann integral. And it's very important because from there, Lebesgue had the idea of how to improve on the Riemann integration. Okay? So the reason, keep in mind, the profound or the most important reason is the fact that the Riemann integral is based on the upper sums and the lower sums are based on these partitions and subintervals, intervals. So let's consider P to be a partition of AB. Okay, so recall what does it mean, a partition? It means that P is equal to numbers between A and B, finite numbers, such that x0 is equal to A, less than x1, less than x2, less than xn, which is equal to B. So in terms of geometry, on the real line, so this is your x0, this is your xn. So you have these points. This is xn minus 1, and this is x1. Okay? So you see, this is where the idea behind the Riemann integrals it gets into troubles because we only consider what? Sets, in other words, subintervals. We take the interval AB and we cut it into subintervals. Okay? So clearly, using the density of uh, of the rationals and the irrationals in every interval, okay, we are going to find a rational and an irrational. So this is very important. Yeah? And therefore, when you look at now to the max and the min of the function f over every subinterval, okay, so we are going to find on the interval xi plus 1, okay, then in this case, the sup of f of x is exactly 1, and the infimum of f of x is 0. Remember that f of x anyway takes two values, 0 and 1. So in every interval, because of the density of the rationals and irrationals, then you have these two values, 1 and 0. So this obviously implies what? That the lower sum of f with respect to this partition P, okay, will become 0, while the upper sum of f with respect to this partition is going to be equal to, I'm sorry, not 1, is the length of the interval. In other words, sum, if you want, this is what's going to be sum. So you have the 1 here, okay, that's the max, times the length of the interval, okay, from 0 to n minus 1, and this will give us b minus a. Okay, so the obviously, because it's independent, the numbers are independent of the partition, then the supremum over all the partitions will give you 0. That's the lower integral. So the lower integral from a to b of f of x dx will be equal to, being the sup of the lower sums of f with respect to all partitions, will be equal to 0, while the upper integral of f of x, being the infimum over all partitions of the upper sums of f with respect to the partitions, will be equal to b minus a. So this is very interesting. So clearly, this means that f is not Riemann integrable. Yeah, but let's say something very interesting again, very important. What happened to the upper uh, Riemann integral? Is like, you see, is the same integral. This upper Riemann integral is the same integral of the function 1 over the entire interval ab. So in other words, what we said earlier is that is like if you take the rationals out and you are integrating only on the irrationals. So if you are able to do that, and that's what Lebesgue did, if you are able to remove the rationals and say, okay, we look at the interval AB as if there is no rational on it, then the function is just equal to 1, and therefore the result is the same. So this is very, very important, okay?